Welcome to the first video on Chapter 11, Testing a Claim. This is where we pull everything together and try to statistically prove some belief. So first we have to concentrate on how do we state our hypothesis. We are going to have two statements. One's going to be called the null hypothesis, or basically the status quo, what we think the population is assumed to be at this time. Then we have the alternative hypothesis, which is what we're trying to get evidence for, which would be against the null hypothesis. So whether we think what people say the population is, whether we think it's actually bigger or smaller or it's just different, that's what the alternative hypothesis is. And the null is denoted by H sub 0, and the alternative is H sub A. Okay, so we could have two types of hypothesis statements. One is a one-sided, the other is a two-sided. For a one-sided, that's when we're going to have a less than or a greater than. And for this example, you just go by the wording. So this is a national study with a scoring range from 0 to 200. And it was found that the mean score for study habits for U.S. college students is 115, standard deviation of 30. Then it goes on talking about normality, simple random sample, which will be important, just like in the last chapter if we were doing the checks. But right now we just care about stating the hypothesis. So the null hypothesis is, or what we're seeking to disprove, is that the mean is equal to 115. And it would be written H sub 0 colon and then the statement, so mu equals 115. The null hypothesis is always equals, and it's always in terms of the population. And then off to the side it says in words what this means. The mean score is 115. You can also just define what mu represents before the hypothesis statement and then not have to write the wording there. And then the alternative, H sub A, mu is greater than 115, and that's because we want to know that students have better attitudes towards school if they're older. So that tells us that it's greater than, assuming a higher number means better study habits. You don't need to say that's null and that's alternative. That's just for the notes. Now, right away, if you ever wrote that the null was X bar equals 115, that's incorrect because that's the sample. The null is written in terms of the population because that's what we're trying to prove information about. So the null is always in terms of the population. So never use P X bar, and also never, when we get to proportions, it's going to be P, not P hat. P hat is incorrect because, again, that's a sample. So null alternative, always write in terms of parameters, not statistics. All right. So two-sided would be if you had a not equals to. So if the wording just said, I want to know if the study habits are different, that's what would give you a two-sided alternative hypothesis. And if we're talking graphically, if we had the normal curve, a one-sided, if we're talking greater than, would be the right tail. If we're talking different, it would be both tails. All right, so now pause the video and just see if you can write the null and alternative hypothesis for each of these. Okay, assuming you have just taken the time to write them out, here are the answers. You don't have to state in a problem whether it's one-sided or two-sided. That's just for the notes here. So we have, notice the null hypotheses are both equals, and just based on the question, the second one is different, so it's not equal. The first one is greater than because it says higher. So you just go by the question. If this were a complete hypothesis test, you would also want to define what mu is. And it's easiest to do that before the question. So like, let's say the first example, mu is the mean household income. Let's see, for the area served by the shopping mall. So just like with confidence intervals where we had to define the parameter PCCI, same thing here. You need to define what your parameter is so you know what mu is representing when we're using the symbols. All right. Good news, conditions for hypothesis tests are exactly the same as for confidence intervals. So everything's exactly the same. Large count depending on whether we're doing means or proportions, same thing. When we get into the full tests, t-test versus z-test is the same as t-interval versus z-interval. You use z-interval for means if you know the population, standard deviation, and t-interval if you don't. But all of these are the same. Randomization usually stated in the problem that it's a simple random sample or that treatments were assigned randomly in the experiment. Real world, again, not AP test world. You should think about these things before you do your studies or experiments instead of afterwards, because you don't want to fail these checks after you've done all the work. You want to do them before you do the work so you know you've done the experiment or study correctly. All right, then we have what's called the test statistic. And that's just going to be your t or z value that we're going to calculate. So in symbols, let's go to symbols. This would be our z statistic. Notice the mu sub 0, that is your null hypothesis value. And if we wanted to change this to a t-test, because we don't know sigma, the only things that would change is that would become a t, and that would become an s. So exact same formula, just one would become a t and an s, and you'd need to know your degrees of freedom, which would be your sample size minus 1. And this is the value that is going to help us figure out what the p-value is that you've seen the memes in the back of my room and I've talked about a little bit. We've come up with this thing called p-value in a couple activities. This is where we really get into what is a p-value. So let's do that. Okay, a p-value, here's the definition, is the probability of getting your observed statistic assuming the null is true. The smaller the p-value, the less likely it is that you would have gotten that sample by chance if the null were true, and so that makes you more confident in rejecting the null. And that's a wording you'll get used to using as you reject the null or you fail to reject the null. So what this means in terms of pictures is, let's take that first example with the score for study habits is 115. So the null was that the mean was 115. So we're using a conditional probability here. We're saying, assuming this is true, what's the probability of getting the sample I got? So let's say I got a sample down here, and I'm not sure what value would give us this sample. So let's just say our sample was 120, okay? So I don't know the standard deviation, so I'm just going to say, what if this gave us a probability that when we did our z-score and our normal CDF, we got this probability came out to be 0.02. That would be our p-value. And that's saying there's only a 2% chance of getting the sample of 120 if 115 is true. And since that's a low probability, probably means 115 isn't really the population mean. So then we're going to reject our null hypothesis, which is called rejecting the null, and say there's statistically significant evidence that the mean is not 115. So the p-value, again, is assuming the null is true, the probability of getting the sample that you got. And if that's a small probability, then the null is probably not true. And we'll get this by using normal CDF, TCDF, also the test statistics, the test calculators buttons will automatically calculate this for you as well. And then a meme, because I like memes, from Princess Bride. All right. And then statistical significance. So what we, in that previous example where I said the p-value was 0.02, we'll say that something is statistically significant, usually if that value is less than 0.05. However, just because something's statistically significant doesn't mean it has any practical importance, because you can collect data on anything and maybe prove some statistical significance, like a higher proportion of AP Stat students prefer to wear red shirts. Like, we could statistically prove whether that's true or not, but does anybody really care? No. So statistically significant doesn't always mean practically important. And so this value for significance is referred to as an alpha value, and usually it's 0.05 is what you're testing against. Just like if we're doing, you can think of it as if we have a 90% confidence here, if we did a two-sided significance test, it would be equivalent to that. It's the same level, but if we're doing a one-sided test, then it's similar to being 95% confident, kind of. So for papers, it's 5%. Usually scientific papers, you're testing against 5% for your alpha. And if it's not, alpha isn't stated, you can kind of default to that. And there's the alpha. So determining significance, if the p-value is larger than your alpha level, then you're going to say you're going to fail to reject the null. So let's instead say I got a p-value instead of 0.02, I got a p-value of 0.1. Since that's greater than an alpha of 0.05, I fail to reject the null. You never accept the null, you just fail to reject it. As well as you never accept the alternative, you just reject the null. And it's a similar thing as to courtrooms. Like, you say somebody's either guilty or not guilty, you don't say they're innocent. You just say you you don't have enough evidence to prove that they're guilty, so they're not guilty. You haven't technically proven their innocence because it's just you might not have had enough evidence. So it's the same idea. We fail to reject the null. We just might not have enough evidence to be able to reject the null. And typical alpha levels, 0.05 is the main one. So if any alpha level is not given, you can say assuming 0.05. It's always a safe bet. Just say that you're assuming that the standard alpha value of 0.05. And then one little note just on significance. It is possible to be significant at one value of alpha, but not at another. And just by looking at the normal curve, you can kind of see that. So if I'm at 0.05 here, if I have a value here at like what would be like kind of 0.04, then I wouldn't have significance at 0.01. because I would be in between those. So it just depends on what your confidence level is, whether you're statistically significant. You got to compare your value to the confidence level. All right, and then just to reiterate the terminology we're going to use, we either reject the null or fail to reject the null based on the p-value, and we never accept the null. In the next videos, we will actually perform a full hypothesis test so you can see the steps. So I will see you in the next video.